Imagine you're on a flight, comfortably cruising at 35,000 feet, perhaps sipping on a beverage and enjoying the in-flight entertainment. Have you ever pondered what happens behind the scenes to ensure your safety? Enter the unsung hero of aviation safety, the airplane black box. Despite its ominous name, this device is neither black nor a simple box. It's a sophisticated piece of technology designed to record every detail of a flight, a brief history, from concept to cockpit. The black box, an essential tool in aviation safety today, was born out of necessity following tragic events. In the 1950s, Dr. David Warren, an Australian scientist, introduced the idea of a device that could record cockpit conversations and critical flight data. His inspiration came after investigating a series of mysterious crashes, including the infamous 1953 disaster of the de Havilland Comet, the world's first commercial jetliner. These accidents left investigators with unanswered questions about what happened in the moments leading to the crashes. Warren's vision was a recorder capable of providing a definitive account of those final moments, but his idea initially faced resistance. Military officials questioned its practicality, dismissing it as unnecessary, while airlines were hesitant, fearing increased costs and potential privacy violations. Despite this skepticism, Warren persisted, refining his invention to address technical challenges and demonstrating its potential benefits. The turning point came in the late 1950s, when the device caught the attention of Australian aviation authorities. By the 1960s, the International Civil Aviation Organization recognized its value, mandating flight recorders in commercial jets worldwide. Since then, the black box has evolved alongside aviation, becoming indispensable in a global industry that now safely carries over 4.5 billion passengers annually. From solving high-profile crash mysteries like the Tenerife disaster of 1977 to informing vital safety protocols. What's in a name? The misnomer of the black box. The name black box might conjure images of a sleek, mysterious device hidden deep within an aircraft, but reality paints a much different picture. These crucial flight recorders are actually bright orange, a deliberate design choice to make them easily identifiable in the aftermath of a crash. Their vibrant color, coupled with heat-resistant, high-visibility paint and reflective tape, ensures they stand out in challenging environments, whether submerged in ocean depths or buried in debris fields. So, where did the term black box come from? Its roots trace back to World War II, when secretive military electronics were encased in black, non-reflective housings to avoid detection. Even as modern flight recorders transitioned to their orange hue for practical reasons, the term persisted. What makes these recorders even more remarkable is the technology enabling their recovery. Each black box is equipped with an underwater locator beacon that activates upon contact with water. This beacon emits signals detectable from depths as great as 20,000 feet, guiding recovery teams to their location. These signals last for up to 90 days, a life-saving feature in cases of remote or underwater crashes, such as the 2009 Air France Flight 447 tragedy. Interestingly, this misnomer encapsulates the evolution of black boxes from a military mystery to a vital safety tool. Whether perched atop icy mountains or lying at the bottom of the ocean, these devices are designed to be seen, recovered, the dynamic duo, FDR and CVR. Airplanes carry two types of flight recorders, each serving a unique purpose. First is the flight data recorder, which meticulously logs flight parameters. In the 1970s, these devices recorded around 100 data points, such as altitude, airspeed, and engine performance. Thanks to modern advancements, today's flight data recorder capture over 3,500 parameters, including control surface positions, electrical system status, and even turbulence levels. This wealth of data spans up to 25 hours, ensuring investigators have everything they need. Second is the cockpit voice recorder, which records conversations between pilots, radio transmissions, and ambient cockpit sounds. Imagine how vital these details are during investigations. A sudden drop in airspeed accompanied by alarm tones or even a subtle shift in pilot tones can provide clues. Recent ICAO regulations require cockpit voice recorder to store 25 hours of audio, far exceeding the earlier 2-hour standard. Together, these two devices are the Sherlock and Watson of aviation safety, crafting the indestructible, the manufacturing process, Making a black box is like designing a superhuman one capable of withstanding the harshest conditions. Black boxes are engineered to endure forces up to 3,400 times the force of gravity, temperatures exceeding 1,000 degrees Celsius, and water pressure at depths of 20,000 feet. This starts with the casing, made from stainless steel or titanium. These materials are carefully selected for their ability to resist corrosion, impact, and extreme heat. Inside the case lies the data acquisition system, the recorder's brain. It uses solid-state technology, replacing earlier magnetic tape systems for durability and efficiency. Manufacturers subject black boxes to rigorous testing, including fire exposure, deep-sea immersion, and shock simulations that mimic crashes. Each step is overseen by aviation authorities like the FAA or EASA to meet global standards. This meticulous process ensures that when the black box is needed, it performs flawlessly, even under the most challenging conditions. Technological advancements. Black box technology has reached unprecedented heights. For example, real-time data streaming is being piloted in modern aircraft. This feature transmits flight data to ground stations via satellites, ensuring that critical information isn't lost even if the black box is unrecoverable. Think of it as a cloud backup for flights, providing near-instant access to vital data. Enhanced data storage capabilities are also transforming the industry. While older black boxes had limited capacity, newer models can record more comprehensive data about aircraft systems, environmental conditions, and even pilot fatigue levels. Some aircraft now feature deployable recorders devices that eject and float in water after an accident, greatly improving recovery times. These innovations aim to solve challenges seen in high-profile cases like Malaysia Airlines Flight MH370. Challenges and considerations. Despite their durability and technological advances, black boxes are not without limitations. Recovery can be a daunting task, particularly when accidents occur in remote or underwater locations. For instance, the wreckage of Air France Flight 447 lay 13,000 feet underwater, requiring 2 years to recover the black box. This has prompted researchers to advocate for solutions like real-time satellite tracking or enhanced locator beacons. Privacy concerns are another issue. Pilots sometimes express discomfort about CVR recordings capturing private conversations. While aviation authorities assure that recordings are only accessed post-incident, the debate highlights the balance between safety and personal privacy. Nonetheless, the wealth of information black boxes provide far outweighs these concerns. The role of black boxes in aviation safety. Black boxes are the unsung heroes of aviation safety, shaping the industry's evolution through the lessons they provide. After the Tenerife disaster in 1977, the deadliest accident in aviation history, black box recordings revealed miscommunications and procedural errors, leading to sweeping changes in cockpit communication protocols. Similarly, data from the 2009 Air France Flight 447 crash spurred improvements in pilot training for handling high-altitude stalls. By analyzing black box data, manufacturers can refine aircraft designs, identify weaknesses, and enhance safety features. Pilots benefit from better training programs based on real-world scenarios. If you found this fascinating, don't forget to give this video a thumbs up and subscribe to our channel for more future videos. Thanks for watching, and we'll see you in the next video.